Have you ever wondered how a people living at the edge of the Arctic with no concrete mixers, no hardware stores, and often not even enough iron to waste on building, managed to create homes that could survive punishing blizzards? At first, it sounds impossible. The Viking world was a place of freezing wind, drifting snow, soaked earth, and winters long enough to break weak houses apart. Yet these communities built shelters that did more than stand up to the cold. They held families, animals, food stores, tools, and fire through seasons that could kill with one bad storm. And they often did it without nails, without cement, and without the kind of rigid materials modern people assume are necessary for strength. So what exactly were they building with? And what did they understand about weather that we have forgotten? The answer begins with a truth that sounds almost too simple. The Vikings did not try to fight winter with hardness alone. They fought it with intelligence. Modern. People often imagine strength as something rigid, stone, steel, concrete, bolts. But in the North Atlantic world, rigidity could fail. A house had to withstand not just weight, but movement. Wind pressed against walls, frost shifted the ground, snow piled heavily on roofs, moisture seeped into every gap and then froze. A badly built structure might seem solid on a clear day, only to begin splitting, sagging, or rotting once winter truly arrived. Viking builders knew this. They built homes that could absorb pressure, shed wind, trap warmth, and work with the landscape instead of standing arrogantly against it. To understand how they did this, we need to forget the image of a Viking house as some rough wooden hut thrown together beside a fjord. In reality, Viking Age houses were often carefully planned longhouses, extended structures built for endurance, efficiency, and shelter. They were not just places to sleep. They were winter machines. A longhouse could contain the household. The hearth, storage, work areas, and sometimes livestock, all arranged under one protective roof. The shape mattered. These buildings were usually long and relatively low, with curved walls or gently bowed lines that helped resist wind. The roof sloped down deeply, sometimes close to the ground, reducing exposed wall area and helping storms move over the structure rather than striking it like a flat target. That shape alone tells us something important. Viking builders understood that blizzard survival was not just about mass, it was about profile. A high, proud structure catches wind. A lower, more aerodynamic one lets it pass. In exposed regions such as Iceland, Greenland, coastal Norway, and the North Atlantic islands, this difference could decide whether a building endured or suffered constant damage. A longhouse sat in the weather like a creature adapted to it, broad-backed, heavy, and close to the earth. The materials they used were equally revealing. Timber was important, of course, especially in Norway and forested regions, but Viking builders were never dependent on one material alone. They used what the landscape offered: wood, turf, stone, earth, sod, driftwood, whalebone in some areas, and woven organic materials. This flexibility was not a sign of poverty in the simple sense. It was a sign of adaptation. In places where long, straight timbers were scarce, builders compensated with turf walls or stone footings. In treeless environments like much of Iceland, turf became a major architectural resource. A turf house might look fragile to the modern eye, but thick turf walls could insulate brilliantly and resist fierce winter exposure far better than a thin wooden wall. This is where the title's mystery starts to open. How do you build something blizzard-proof without nails or cement? One answer is that you stop depending on brittle, point-fastened systems in the first place. Viking builders often relied on joinery, weight, pressure, layering, and interlocking forms. Timber frames could be fitted together with carved joints, pegs, lashings, and carefully balanced loads. Stone did not always need mortar if it was well placed. Turf blocks, cut and stacked correctly, could form dense, stable walls held together by their own mass and the way they settled. The building stayed together not because a chemical bond glued everything rigidly in place, but because each part supported the others. In many ways, this made Viking houses more resilient under northern conditions. Cement and modern mortars can crack when conditions shift if the overall structure is badly designed. A dry-stacked stone base, by contrast, can move slightly with the ground. A timber frame joined by skill rather than metal can flex under stress. Turf walls can compress, settle, and continue functioning. What mattered was not mechanical perfection. It was whether the house could survive repeated punishment. The foundation was critical. A Viking house had to begin with the ground, and in a cold climate, the ground itself could not be trusted. Wet soil became mud, frozen soil expanded, seasonal thaw turned firmness into softness. So builders often selected sites with care, looking for slight elevation, drainage, and some shelter from prevailing winds. A good site could save a mediocre building. A bad site could doom even a strong one. Stone footings were often used to lift timbers away from persistent damp and to create a more stable base. In turf structures, stone and earth worked together to anchor the house against both weather and shifting ground. The best Viking builders were not merely assembling materials, they were reading terrain. Then there were the walls, which modern observers often underestimate because they do not look engineered in the modern sense. But Viking walls were doing multiple jobs at once. They had to block wind, hold warmth, shed moisture, bear roof loads, and endure seasonal stress. In timber-framed longhouses, the wooden skeleton carried much of the load, while wall infill or cladding contributed enclosure and insulation. In turf-heavy buildings, the walls themselves became massive thermal barriers. A thick turf wall was not delicate. It was a dense, living block of earth and roots, sometimes layered with stone or timber, able to slow cold, absorb pressure, and reduce drafts. Such a wall might not look elegant, but in a blizzard, elegance is irrelevant. The roof may have been the most demanding part of all. Snow is not only cold, it is heavy. Wind-driven snow is worse because it can pile unevenly and exploit weakness. A Viking roof had to carry weight without collapsing and had to do so with materials that were often organic, local, and limited. The solution was not a thin flat span, but a strong sloping form supported by closely understood framing. Timber rafters, ridge elements, and internal posts distributed loads downward. Coverings might include wooden shingles, thatch, birch bark, or turf layered over waterproofing materials. Turf roofs in particular were astonishingly effective in the north. Heavy, yes, but that heaviness was part of the logic. Properly supported, a turf roof insulated against cold, resisted wind uplift, and helped pin the structure into the landscape. Snow accumulating on top added more weight, but also more insulation, and if the roof angle and support system were right, the house could bear it. Inside, the structure often relied on rows of posts that modern people might think wasteful or inconvenient. But those posts were crucial. They carried the roof load, especially in larger longhouses, reducing the stress on outer walls and allowing the whole building to endure pressure more effectively. The interior layout was therefore tied directly to structural survival. Benches, sleeping platforms, storage zones, and the central hearth all existed within a frame that was doing real mechanical work. Viking architecture did not separate living space from structural logic. They were one and the same. Another reason these houses survived blizzards is that they were rarely isolated as pure objects. They were part of a broader homestead arrangement. Outbuildings, earthworks, fences, and natural topography all affected exposure. A main house might be positioned where a slope broke the wind, where other buildings created partial shelter, or where drifting snow would collect in less dangerous ways. This was landscape engineering in a practical sense. A Viking farm was not just a house placed on land. It was a system of relationships between structures, animals, paths, drainage, and weather. And weather, of course, was the ultimate teacher. Viking builders did not learn from theory first. They learned from what storms destroyed. In a northern settlement, failure was highly visible. A roof that lifted, a wall that leaked, a poorly drained site that turned into freezing mud, these were not abstract design flaws. They threatened food, warmth, livestock, and life. Over generations, communities would remember which forms endured and which did not. Building knowledge became cultural memory. It passed not through architectural drawings, but through repetition, repair, apprenticeship, and survival. This helps explain why the absence of nails or cement was not necessarily a disadvantage. Iron was valuable and often better used for tools, weapons, and fittings than squandered in large amounts on building. Mortared stone required traditions, materials, and labor systems not always suited to the Viking world's environments. What Viking builders had instead was a different kind of sophistication, a mastery of assembly through fit, weight, and environmental intelligence. They built in a way that respected scarcity and rewarded maintenance. A house was not something finished forever. It was something tended, patched, re-roofed, strengthened, and kept alive. And that idea of a house as a living structure may be the key to understanding its success. A Viking home was not blizzard-proof because it was invincible. It was blizzard-proof because it was adaptable. Turf could be repaired, timber joints could be tightened, roof coverings could be renewed, walls could be reinforced. Weaknesses noticed after one winter could be corrected before the next. These houses were not monuments. They were tools for survival. The more closely we look, the stranger the achievement becomes. These people built in landscapes where winter could erase paths, bury doorways, soak walls, freeze earth solid, and rip at roofs for days without pause. They did it with materials cut from the ground, dragged from the sea, split from forest, or stripped from the very surface of the land. No steel brackets, no concrete slab, no industrial insulation, and yet some of their methods were so effective that later North Atlantic building traditions continued to echo them for centuries. That is not an accident, it is evidence of a hard-earned architectural wisdom. Still, a strong wall and a heavy roof were only part of the story. Because the real secret of these houses was not just how they stood up in a blizzard, but how they stayed livable once the storm had sealed everyone inside. When the wind found every weakness, the snow pressed deeper against the walls, and the line between a shelter and a trap depended on choices made long before the first winter arrived. When the blizzard finally arrived, a Viking house faced its real test. Not in the summer when the turf was green and the roof looked solid, and not in the autumn when repairs could still be made under a clear sky. The real judgment came when the wind began to roar across the settlement, when snow drove sideways so hard it erased distance, and when the world outside narrowed to whiteness, darkness, and the sound of weather trying to break in. At that moment, a house had to do more than stand. It had to shelter heat, control smoke, protect food, hold people together, and survive days of pressure without becoming a coffin of cold or a fire trap. And that is where Viking building reveals its deepest intelligence. The first thing to understand is that blizzard-proof did not mean storm-proof in the modern fantasy sense. A Viking house was not a sealed capsule immune to nature. Wind still found seams, snow still piled against walls, smoke still needed careful management, roof timbers still groaned under load. But these buildings were designed with the expectation that winter would intrude, and that survival depended not on eliminating every threat, but on reducing each one to something manageable. The structure did not need to defeat the storm completely. It needed to remain stable and habitable longer than the storm could endure. That begins with heat. A house can have the strongest frame in the world, but if it cannot keep warmth inside, it will fail the people living there. Viking builders understood that shelter and insulation were inseparable. Thick turf walls were especially powerful in this regard. To a modern eye, a wall made of earth and grass sounds damp and weak. In practice, when cut well and stacked thickly, turf became a dense insulating barrier. It trapped air, blocked wind, and slowed the escape of heat. In a blizzard, when the outside air turned viciously cold and moving, that thickness mattered more than elegance. The wall did not need to be smooth. It needed to be massive, and mass worked in more than one way. Thick walls and heavy roofs gave Viking houses thermal stability. Once the interior had been warmed by people, animals, lamps, and especially the hearth, that warmth did not vanish instantly. The building itself helped hold it. This was crucial in long northern nights, where a fire might burn lower for part of the night and where fuel always had to be used carefully. A house built of light, thin materials can lose heat quickly and punish every lapse. A house built with turf, earth, timber, and layered roofing retained warmth more slowly and forgave small fluctuations better. In that sense, Viking houses were not just shields, they were reservoirs. The hearth sat at the center of that thermal world. Just as on Viking ships, everything depended on balance. In the house, everything depended on the fire. It provided heat, cooked food, dried clothing, warmed tools, softened frozen hands, and anchored the social life of the household. But the relationship between house and hearth had to be handled with precision. Too much openness in the roof or walls, and precious heat vanished. Too little ventilation, and smoke became dangerous. This was one of the subtle arts of Viking domestic design. The house had to breathe, but only just enough. Earlier and simpler houses often allowed smoke to gather in the upper interior before escaping through vents, roof openings, or the porous layers of roofing itself. To us, this sounds unpleasant, even unhealthy, and often it was. but it was also useful. That layer of warm smoke beneath the rafters helped dry the roof structure, reduced moisture damage, and may even have discouraged pests. More importantly, it was part of a controlled interior climate. Viking households did not expect clean, evenly heated, brightly ventilated rooms in the modern sense. They expected a range of conditions within the house, with the lower living zone warmest where it counted and the upper, smoky zone serving structural and practical purposes. Comfort was local, not uniform. This local approach to comfort explains much about the longhouse interior. Viking houses were not giant empty volumes heated for convenience. They were organized around usable warm zones. Benches lined the walls, offering places to sit, work, rest, and sleep. These bench areas often doubled as storage and sleeping platforms, raising people slightly above the coldest floor level and concentrating daily life where warmth could be best used. Beds or sleeping areas were not scattered in separate, isolated bedrooms in the modern sense. They were integrated into the shared thermal life of the house. Curtains, wool, furs, and layered textiles further trapped warmth close to the body. In the worst weather, survival came from narrowing life inward. Animals also played a role, especially in more practical farm buildings where human and animal shelter were closely connected. Bringing livestock into or near the main structure during severe weather was not merely a convenience or a theft prevention measure, it was thermal strategy. Large animals generate a surprising amount of heat. Their presence could raise the temperature of enclosed spaces, reduce exposure, and make it easier for both beasts and people to survive the storm. This arrangement also protected valuable livestock from snow, wind, and freezing. Viking farm architecture, like much of early northern architecture, often blurred the line between domestic and agricultural space because winter made such separation less important than mutual survival. Then there was the roof, perhaps the most visually dramatic part of a Viking blizzard-proof house. A good roof had to survive downward weight and upward force at the same time. Snow pressed from above. Wind tried to pry from below and the sides. A light roof might be torn free. A badly supported one might collapse inward. Viking builders responded with layered heaviness and smart framing. Turf roofs, though heavy, resisted wind uplift precisely because of their weight. Underneath, birch bark or similar materials helped shed moisture. Timber rafters and internal supports distributed the load, while the low-slung shape reduced the force of the wind. The roof did not merely sit on the house, it was part of the house's bond with the earth. This is why the absence of nails becomes less mysterious the longer you study it. Nails are useful, but they are not the only way to hold a building together. In fact, in a climate of movement, where timbers swell and shrink, earth settles, wind flexes walls, and frost shifts the ground, a building that depends entirely on rigid metal fastening can still fail if its deeper structure is wrong. Viking houses instead relied on joinery, pegged connections, weighted roofing, interlocked layers, and the geometry of load paths. Their builders knew where pressure traveled. They knew what needed to flex and what needed to stay. Dense, they were using an engineering logic rooted in observation rather than equations, but it was engineering all the same. One of the most overlooked parts of that engineering was maintenance. A Viking house was not considered complete in the modern sense, finished once and forgotten. It was part of the annual cycle of labor. Turf needed patching. Drainage needed checking. Smoke vents had to remain functional. Timber could rot, warp, or loosen. Snow behavior around the house had to be noticed. Weak points discovered in one storm would be remembered and corrected before the next winter if possible. This continuous repair culture made the house stronger over time. The settlement learned. A blizzard was not just weather, it was feedback. That feedback shaped the entire layout of Viking homesteads. Houses were rarely placed randomly. Builders paid attention to slopes, windbreaks, water flow, and exposure. A slight rise could keep the house drier. A nearby ridge or outbuilding could break the force of prevailing winds. Entrances could be placed away from the harshest exposure. In some landscapes, earth banks or the very pattern of neighboring structures helped reduce drifting snow or create pockets of shelter. Viking architecture did not end at the walls. It extended into the site itself. The house and the land were working together, and food storage was part of the same winter system. A house sealed against cold but lacking secure access to food would still fail. So Viking building often involved a broader survival network: outbuildings, storage pits, lofts, preserved meat and fish, grain, Tools, fodder, and access routes kept usable despite snow. A blizzard-proof house was never just one room with a roof. It was the heart of a larger strategy that allowed the household to stay put when movement became dangerous or impossible. The building was a center of endurance, not just a container. Still, for all their intelligence, these houses were never invulnerable. Roofs could fail, snow could block exits, smoke could accumulate dangerously, fires could escape the hearth and consume the very structure built to preserve life. Turf walls could weaken if water infiltration went unchecked. Timber scarcity could force compromises. In Greenland and Iceland especially, where resources were limited and conditions severe, architecture often depended on constant vigilance. This matters because it keeps the Viking achievement grounded in reality. Their houses were brilliant, but they were not magical. They worked because people worked with them. And perhaps that is the most important insight of all. A Viking blizzard-proof house was not a static object. It was a relationship between materials, weather, labor, and memory. The people who lived in it knew its sounds. They knew how the roof responded in wind. They knew where drafts slipped in first, where snow drifted deepest, where the turf stayed wetter, where the fire burned best, where animals should be placed, and when repairs could no longer wait. The house was part of the household's knowledge. Survival was not hidden in the walls alone. It was also hidden in habit. That is why these homes could endure in places that seem almost impossible to inhabit. The Vikings were not protected by superior technology in the modern sense. They were protected by adaptation. They built with whatever the land gave them, but they used it with extraordinary precision. Turf became insulation. Stone became anchoring mass. Timber became flexible frame. Smoke became part of climate control. Animal heat became part of shelter. Snow itself, once understood, became less an enemy than a force to be anticipated and managed. So when we ask how Vikings built blizzard-proof houses without nails or cement, the answer is larger than a building trick. They did it by refusing to depend on one miracle material or one rigid solution. They built low, thick, layered, and heavy. They joined rather than merely fastened. They weighted rather than glued. They insulated with earth. They shaped roofs for wind and walls for warmth. They placed homes where land offered help, and they repaired what winter taught them to repair. These houses survived because they were designed not as monuments to permanence, but as living instruments of endurance. And that may be the most remarkable thing about them. In a world of storms, shifting ground, scarce iron, and endless cold, the Vikings created homes that could outlast the season not by overpowering nature, but by studying it closely enough to build in its language. Where we might have reached for cement and bolts, they reached for turf, timber, stone, weight, and memory. And in the howl of a northern blizzard, with snow banking against the walls and firelight pulsing beneath a heavy roof, that knowledge could mean the difference between a house that disappeared into winter and one that held.